Have you ever wondered how the future of space exploration and high-speed flight is being forged? Prepare to delve into the cutting-edge world of New Frontier Aerospace, a company at the forefront of propulsion innovation. They are not just building rocket engines, they are redefining what's possible with advanced manufacturing and groundbreaking thermodynamic cycles. New Frontier Aerospace, based in Kent, Washington, is rapidly emerging as a pivotal player in the aerospace industry. Their focus on additive manufacturing, specifically 3D printing, for rocket engine components is a game changer. This approach allows for unprecedented design complexity and rapid iteration, fundamentally altering the traditional development cycle of propulsion systems. Their work is not merely theoretical, it's backed by tangible progress and successful tests. This blend of innovative design and practical validation positions them uniquely. They are pushing the boundaries of what compact, high-performance engines can achieve. At the heart of New Frontier Aerospace's endeavors is the Mjolnir rocket engine, a name that evokes power and precision. This engine represents a significant leap forward in propulsion technology. Its design and operational principles are a testament to modern engineering prowess. The Mjolnir engine has already undergone successful hot-fire tests, a critical milestone in engine development. These tests validate the engine's performance, stability, and structural integrity under operational conditions. It's a crucial step from design to reality. The Mjolnir engine is a prime example of the transformative power of 3D printing in aerospace. Additive manufacturing allows for the creation of highly complex geometries that are impossible with traditional methods. This includes integrated cooling channels, intricate injector designs, and optimized combustion chambers. This technology significantly reduces part count, leading to lighter, more robust engines. It also accelerates the manufacturing process, cutting down lead times from months to weeks. For aerospace engineers, this means faster design iterations and quicker deployment of new technologies. Mjolnir boasts a compact pump-fed design, a crucial characteristic for high-performance engines. Unlike pressure-fed systems that rely on heavy tanks of pressurized gas, pump-fed engines use turbopumps to deliver propellants to the combustion chamber. The compact nature of Mjolnir is also vital for its intended applications. Smaller, more powerful engines enable sleeker vehicle designs and greater payload capacity. This efficiency in packaging is a key design challenge in modern aerospace. Perhaps the most impressive technical aspect of Mjolnir is its utilization of a full-flow staged combustion (FFSC) cycle. This is one of the most advanced and efficient rocket engine cycles known. In an FFSC engine, both the fuel and oxidizer are fully gasified and burned in separate pre-burners before entering the main combustion chamber. This process drives turbines that power the propellant pumps. The key advantage is that all propellants pass through the main combustion chamber, maximizing efficiency and specific impulse. It also significantly reduces turbopump wear compared to other cycles as the turbine drive gases are cooler and cleaner. This cycle is notoriously complex to engineer, making Mjolnir's successful development a significant achievement. Mjolnir uses liquid natural gas, LNG, primarily methane as its fuel, paired with liquid oxygen, LOX, as the oxidizer. Methane offers several compelling advantages for rocket propulsion. It provides excellent performance when combined with LOX, yielding a high specific impulse. Furthermore, methane is relatively dense, allowing for smaller tank volumes, and it's storable at higher temperatures than liquid hydrogen, simplifying ground operations. Crucially, methane burns cleanly, reducing coking issues that can plague engines using hydrocarbon fuels. If sourced from bio-waste, LNG can even be considered net carbon negative, aligning with growing demands for sustainable aerospace practices. The Mjolnir engine is not a one-off demonstrator. It's a versatile propulsion system designed for multiple high-impact applications. Its unique combination of efficiency, power, and compact size makes it suitable for a range of cutting-edge aerospace vehicles. These applications highlight new Frontier Aerospace's vision for both atmospheric and orbital flight. The strategic deployment of Mjolnir across different platforms underscores its adaptability. This multi-purpose approach maximizes the return on investment in engine development. It also demonstrates the engine's robust design and operational flexibility. One of the most exciting applications for Mjolnir is the Pathfinder Hypersonic VTOL UAS unmanned aerial system. This vehicle is designed for vertical takeoff and landing (VTOL) and capable of sustained flight at hypersonic speeds exceeding Mach 5. The first hovering flight is ambitiously planned for early 2026. Hypersonic flight presents immense engineering challenges, particularly concerning thermal management and propulsion. Mjolnir's efficiency and compact form factor are critical for enabling such a vehicle. A VTOL capability adds significant operational flexibility, allowing deployment from diverse locations without traditional runways. This technology has profound implications for rapid reconnaissance, global reach, and advanced logistics. Beyond atmospheric flight, Mjolnir is slated to power the Bifrost orbital transfer spacecraft, with its first flight in space targeted for 2027. An orbital transfer spacecraft is designed to move payloads or other spacecraft between different orbits, for example, from low Earth orbit (LEO) to geostationary orbit (GEO), or even for lunar and interplanetary missions. For in-space propulsion, efficiency is paramount, as every kilogram of propellant saved translates to more payload or longer mission duration. Mjolnir's full-flow staged combustion cycle and high specific impulse with LNG make it an ideal candidate for such demanding missions. Bifrost could revolutionize space logistics, enabling more flexible and cost-effective deployment of satellites and other orbital assets. New Frontier Aerospace is also offering Mjolnir as a standalone product for other aerospace ventures. This strategic move recognizes the significant investment and expertise required to develop a high-performance rocket engine. Many companies, particularly those focused on vehicle design or specific mission profiles, may prefer to procure a proven engine rather than undertaking the complex and costly development themselves. This business model allows New Frontier Aerospace to become a key supplier in the burgeoning space economy. Potential customers could include small satellite launch providers, in-space tug developers, or even advanced aircraft manufacturers. Offering Mjolnir commercially accelerates innovation across the industry by providing access to cutting-edge propulsion technology. The development of such advanced propulsion systems requires substantial investment and strategic partnerships. New Frontier Aerospace has successfully secured funding from key government entities, underscoring the national importance and potential impact of their work. This financial backing is crucial for accelerating research, development, and testing phases. The support from these organizations validates the technical merit and strategic value of Mjolnir. It also provides the necessary resources to scale up operations and push towards higher thrust capabilities. This funding is a testament to the engine's potential to meet future aerospace demands. NASA, the National Aeronautics and Space Administration, has provided funding for Mjolnir's development. NASA's involvement often signifies a technology's potential to contribute to future space exploration goals. Their support aligns with their broader initiatives to foster innovation in propulsion, which is critical for missions to the Moon, Mars, and beyond. NASA's investment helps de-risk advanced technologies, making them more viable for commercial and governmental applications. This partnership leverages New Frontier Aerospace's agility and innovation with NASA's long-term strategic vision and technical expertise. It's a symbiotic relationship driving progress. Further funding has come from National Security Innovation Capital, NSIC, a part of the Pentagon's Defense Innovation Unit, DIU. NSIC focuses on accelerating the development of dual-use technologies that serve both commercial and national security interests. Their investment highlights the strategic importance of Mjolnir for defense applications, particularly in areas like hypersonic flight and rapid space access. This funding stream emphasizes the engine's potential to enhance national capabilities in critical domains. It also demonstrates a commitment to leveraging private sector innovation to address pressing national security challenges. The partnership with NSIC underscores the versatility and strategic value of new Frontier Aerospace's technology. The current Mjolnir engine prototype can output 3,000 pounds of thrust, a significant achievement for a compact, advanced demonstrator. This tenfold increase in thrust will unlock even more demanding applications, from larger launch vehicles to more powerful hypersonic aircraft. Scaling up an engine while maintaining efficiency and reliability is a complex engineering challenge. It requires meticulous design, advanced materials, and rigorous testing. This planned growth trajectory positions Mjolnir as a serious contender in the high-performance propulsion market. New Frontier Aerospace is not just building engines, they are building the future of aerospace. Their innovative approach to 3D printing, their mastery of the full-flow staged combustion cycle, and their commitment to sustainable propellants like LNG are setting new industry standards. The Mjolnir engine, with its diverse applications and ambitious thrust targets, is a testament to human ingenuity and engineering excellence. Are you an aerospace engineer, a tech enthusiast, or simply fascinated by the frontiers of innovation? Dive deeper into the world of advanced propulsion. Explore New Frontier Aerospace's work, research the intricacies of full-flow staged combustion, and consider how additive manufacturing is reshaping industries. Share your thoughts in the comments below, subscribe for more insights into groundbreaking technologies, and join the conversation about the future of flight and space exploration. Hey, if you're enjoying this video and want to see more like it, don't forget to hit subscribe and turn on the notification bell so you never miss an update.